Congratulations, statistics people. You've made it to the third binomial video, the last in the binomial trilogy, if you will. In part one, we looked at ways of identifying a binomial. In part two, we took the words of the question and tried to write it in a way such that the binomial distribution could be used. And in this, the last chapter, we're going to take a look at how we actually solve binomials using the common tools available to us. Sound like a deal? Let's do it in about 6 minutes, shall we? All right, let's go.
Give me 6 minutes and I'll teach you something new. Now, let's get to work.
Mark here from 6 Minute Statistics, and I really am glad that you made it back for the third and final, yes, that is final chapter in the binomial distribution. Before we get started, why don't you pause and head over to my Etsy store and check out my I Survived the Binomial Distribution t-shirts that are for sale. Not really, but you could get one of these bad boys. Ooh. What do you think? Nothing? Really? Fine. How about we just finish this series on the binomial probability distribution? As I mentioned, we've looked at identifying binomials. We've looked at trying to write them in a way that we can solve them. And in this, our third video, I want to show you examples of the binomial tools we have available to us. The two most common tools are binomial tables and using software that will find binomial probabilities for us. To illustrate, let's take a look at an example. In my prior videos, we defined a success to be a home that has an operable or working smoke detector. My firefighter friends have already told us that 80% of all homes have operable smoke detectors. Suppose we take a sample of 20 homes and we want to check this claim. In part one of the binomial series, we defined X to be the number of homes in the sample with an operable smoke detector, and we found, or we stated, that X was what we called a binomial random variable with values of n equal 20 and a probability success P equal to 0.8. I also looked at the three questions that you see on the screen right now. In part two of the series, we took some time trying to go through and take a look at these questions and rethinking them or rewriting them in a way that we could solve using binomial tools. The way that we came up with was using less than or equal to or cumulative probabilities. It's not the only way to solve them, but I believe it's probably the most straightforward and simple way of solving them. If any of that's confusing to you, I'm going to link to my prior binomial videos, and I want you to go back, take a look at those before you finish it off here in this video. All right, let's start with some binomial tables. Usually, tables are grouped by sample size and then by the probability of success. So in this case, we're going to have to locate the n equal 20 table and then head over to the p equal 0.8 column. I'm going to show you on the screen the results from just this column, and now we're going to use that to try to answer the questions. Sometimes you're going to run into a problem that doesn't give you cumulative probabilities. You're going to have to adapt and add probabilities together if that's the case, but more often than not, you're going to be able to find cumulative binomial tables. Once you get to the correct table, now it's just a matter of matching up the correct number that you're interested in the table and finding the probability or probabilities that you want to use and then plugging them into our little probability expressions. Pretty straightforward, pretty simple, right? I'm going to go through and show you how to solve each of those problems that I asked you in that second video. All right, so that's how we use binomial tables. What about software? Well, first off, there's way too many programs out there for me to illustrate each one. The good news, however, is that they all work kind of sort of the same way. Every program you're going to run into is going to require you to enter the value of n, the sample size, and the value of p, the probability of success, into the software. Then you got to figure out how you're going to generate the probabilities you want and the types of probabilities that you're getting. I'm going to show you how to use the Excel software package, and you can probably adapt to whatever software you're using. In Excel, we enter the sample size in the trials part of the menu. We enter our value of P in a probability of a success, and then we type true in the cumulative part of the menu, and by typing true, we're telling Excel that we want those less than or equal to, or what we're calling cumulative probabilities. Some computer programs give several different probability options when they give probabilities. It's up to you to choose the option you want, but being a fan of the Dumbledore dot diagram, I really like less than or equal to probabilities, and I really encourage you to like them as well. In the last video, I gave you 2 additional probabilities to find at the end of the video if you made it that far. I'm going to use Excel now to answer those problems. And again, once we find the cumulative probabilities, we just plug them into the appropriate spot and solve. Sometimes we subtract 2 numbers apart. Sometimes we subtract a number from one. As you get more comfortable with the binomial, you'll get a better feel what to do. All right, one last word on tables versus the computer software. My students will sometimes ask, why do we have to use tables in one situation and computer software in the other? Generally speaking, I don't care what you use. They give you the same information. Hopefully that's been pointed out in this video. The key is convenience. If I'm giving an in-class exam, I'll print off a table for everyone to look at. If I'm giving a take-home exam or a do it on your own type of project, you can use the software. It really doesn't matter. I'll add one more into the mix. If you're using the binomial formula, if you're in a class or you're in a situation where you have to use that, sorry. I'm not going to cover the binomial formula at all. I think it's antiquated, it does the job, but there are much, much better tools out that I'm going to use before I ever reach for a binomial formula. So if that's you, I feel your pain. Yeah, sorry. And with that, the binomial distribution puzzle has been solved. Cue the confetti. Wonder if I can do that in editing. We'll find out. Now it's your turn. Take a look at some binomial problems, see if you can identify them first, write the words in a less than or equal to format so you can solve them, and then use your tool of choice, whether it's a table, whether it is a software program, and see that you can solve binomial probabilities. Your next step, as always, is it's time for you, my friends, to get to work. Hope you're having a great day. I'll see you soon. So long.